And then we are going to get started now, so a good morning. And that was the Blues Brothers, and what was your last cut on that, Ernie? Shake a tail feather. Now, I keep telling you, you got to choose these with some kind of, tie it together to the mathematics. We could have done Think, we could have done Chicago, where 7 and 1 is 8 or something like that in Chicago. You just have to get this going better, Ernie. I don't know. Yeah. Shake the numerator. Robert? Okay. We are working in material that I have been told has not gone as well as some of the other sections. So we've been spending the last few minutes discussing the frustrations of algebra and pre-algebra. And we might argue the frustrations of learning. I think it goes in a kind of general sort of way. One of the concerns, and I think to put this in perspective, and I say this from the standpoint that I know that we are broadcasting to all the community colleges in the state through 3C Media Solutions. And so your frustrations become a lot of other people's frustrations. And the things we address here may be addressed in other campuses. But part of what we are trying to do is cover a curriculum. Now, to put that in perspective, each course, we make agreements as a campus to cover certain material to get ready for another course. And that is called a course outline. And the curriculum that we take is often determined by what's in a book, but we choose the books because we want to cover that material. So it's a little bit of a question, which comes first, the chicken or the egg? But in terms of what we're doing, there's a kind of tying together of the two. And we chose this book for what we're doing because, one, it ties so well into what's done in Math 10. And as I look at a section, okay, and I think of what is in each section, and I have an obligation to the content to cover a certain amount of material, which means I have predetermined what we're covering every day, and that is available to you as you look online. But as you think about it, I've said each day that about 50 to 70% of these sections we've been going through, it's what we did in Math 10. Now, other people watching this in other colleges may not have that background, but you do. And I make an assumption on that background, and that is that you can do all that still. Now, that's a big assumption on my part, and it places a burden on yours. Because everything that we've done before, as well as you did in that previous class, I expect you to be able to do that today. So I don't see a need to go back and do or discuss nearly 50 to 70% of the content in a section. I don't see a need for that. You're supposed to still be able to do that. And you have some obligation to go back and work on that, which is a big commitment. So the new material we tie together based on what we did before. And that's where it gives the sense that if we're only spending a half hour on that, that may be going faster than you like. The general balance, and just again speaking in terms of a kind of general approach to mathematics at any college, you'll find a general balance at about 20 to 30 minutes of an hour answering questions, tying together problems from the previous set of material, because that's where you finally understand sometimes what happened, and then about a half hour in a new presentation. In all the years I've been teaching, whether or not I've been on a camera or not, and I've only been doing this in terms of a camera kind of presentation for about a decade, but in terms of the balance of how long I've been teaching, number of years before that, and the same balance is there that I do when I'm on camera. The one thing you benefit from when I'm on camera is my board presentations on camera are so much different than they are if I'm not under that discipline. And you have those board presentations that don't get erased. I mean, everything's there. So there are a lot of advantages you benefit from, and not the least of which is you can go over and watch a VHS tape at any time of the presentation and see a second go-around if you wish. You can go home, and at 3 o'clock in the afternoon, you can watch the full presentation on a television broadcast. You can go on 3C Media Solution and watch a broadcast of it. So there are a lot of options here. And I understand the frustration you're feeling, and it happens to be with Section 5.7, and I'm going to try to answer questions today. What I will remind you is that tomorrow is a tutorial in which we will be able to answer questions tomorrow. And that is a luxury that not another class at this college has, other than the 10 and the 20 in the bridge program. End of story. Not a single class. So that's an advantage of the process. And there's no way of really still solving all the difficulties I think you're feeling. But keep in mind, this is, as a process, maybe as much as you could ever be able in a position to have. And then we have one other thing, and we talk about it, and this is something that as I talk about Sarah, who's teaching a Math 20, and the things that she's doing, this is my wife, she's not experiencing some of the same interactions that I am with you. And part of that has to do that we've been together for a year. And so you're much more upfront with me. You're much more informative to me when things are working or not working. And so we'll try to build on that and make it happen. Part of our dilemma, and this at various times is at different levels, but when we have a Friday in a tutorial and I have 50% of you not here, I'm sorry. The impact in that is something you'll feel much in the same way if you've lost sleep for 48 hours and try to catch up. It doesn't happen overnight. It doesn't happen in 1 week. And if you have things that are happening in your life, and we all do, where things just don't go as smoothly as you want, those take their toll and you don't bounce back and suddenly everything has clarity. It is a battle. It is something you fight through and try to survive at the end. And we hit times when it just seems like you're hitting the wall temporarily. We work together to do that, but the things you have to do, you've got to be here for the tutorials. You have to be here on a Friday so you can ask those questions. You have to be here so you can take those quizzes. You have to be here on a daily basis, and what you're finding is something that I don't think you realize. If you were in a regular class and you missed 3 days, you probably will not pass the course and have to drop because there is no way of recovering. 3 or 4 days out of many of the courses is enough to bury you, and you end up dropping. We have a luxury because, one, you work together, you talk together, you help each other, you have opportunities for the tutorials, and you are managing to survive impacts on your lives that would make it impossible for you to continue in most courses. That's the reality. And I'm serious about that. And I don't care what the reasons are for the absences. The point being, for a third to a half of this class, enough absences because of things you can't control, but do that in a regular class without the support mechanism that's here, or the abilities you have, and you would not, at this point, be in the class, and you would have dropped. That's the big difference. So we're battling a lot of things. And in this economic turmoil, and in this society as it is right now, to survive on a day-by-day basis is terribly difficult. And to survive all the things that happen to us, from illness and sickness and all the things that we can't control, if you are just making it and surviving, that's a victory. And we'll try to build on that, and we'll try to make it happen. But understand that typically, 4 days out, miss a week, you're gone. No hope of catching up. We have the tutorials in the afternoon. We have the tutorials in the morning. We have a tutorial on Friday. You have the VHS tapes. you can come in and talk. That doesn't happen in most of the curriculum. And so for those of you who are watching what we're doing here at Modesto, and you're watching from another campus, this, in my view, after a lot of years, is as good as it gets as a program and the best that we can provide. And that's why, to me, what you are able to accomplish, and if we can make it happen and get through all this garbage that we're going through, is just terribly important, because there aren't very many opportunities like that. So that's a long-winded answer to some of your frustrations. Let's look at details in 5.7. We're going to come back and spend time with that again tomorrow. But in 5.7, it was order of operations, simplified, and evaluating. Three different ideas. Order of operations. There's one of those things that I'm going to talk about in a moment here that somehow they got glossed over. It came in yesterday's tutorial in the afternoon. And this isn't a specific problem, but I'm going to write something on the board. And by the way, the fact that we're working with fractions does create a level of frustration. But let's say I have 3.5, and I have -5, and I have parentheses, and I have a quarter minus an eighth. Order of operations. What is not clear, and this is just about the way the problem was written, and I have that fourth and that eighth looking pretty sick looking at it in the monitor. But the point is, that is a multiplication implied. And this did not come out yesterday as understood in the questions I was looking at as they were being asked in the afternoon. Now, you do parentheses first. Now, if I do the parentheses first, this is, of course, 2/8 minus 1/8. So you could have done this and said this all simplifies to 1/8. And you have a 5 out here and a 3.5. And the thing I had people talking about was, I'm going to subtract 5 from 3.5 before I do anything else. And not understanding something that's very important here, that is a multiplication. You don't have to have the dot there. It means multiply because of the parentheses. Order of operations. Do that first. The next step should not have been a problem. And the problem here was not with the pre-algebra. It was with something that you should know. I'm just going to pull this much out and say you're going to multiply 5 times 1/8. Now, I know what's wrong here. We don't use x's. We're using a dot. Now, I think what you're getting blown away by, you see that as a mixed number, and it isn't. But I think you see it as a mixed number, not even knowing you're seeing it as a mixed number. There is an implied 1 there. That becomes 5/8. And I tried to explain that yesterday afternoon a couple of times, and it caused problems because this sort of pulled it out of what you understood half a semester ago and got it into, I don't know what I'm doing. You multiply the numerators, you multiply the denominators, and you get a 5/8. In the same way, if I had given this problem to you, as I did in Math 10, you said, yes, 5/8. Pull the x out, put a dot, and suddenly, and I'm not sure why, but I have a suspicion, it's because that looks like 5 and an 1/8, and you're saying, but 8 times 5 is 40 plus 1. Sandra?
Isn't it a negative 5/8?
I haven't done anything with the negative sign. Yes, it will be a negative 5/8. But what I'm getting at, this whole thing hit a wall yesterday in trying to explain that. That is a problem that shouldn't be as difficult because, yes, as Sandra's saying, you have a negative sign there. And yes, at this point, I think it's to your advantage to go ahead and rewrite that as an improper fraction, which is 7/2. And then you're going to go ahead and write that over a common denominator. And the 8 is your common denominator, so that's going to be a 4 here, so 28 over 4. And in this problem, I would be done with an intermediate step of 28 minus, Curl put an 8 there, not a 4. Sorry about that. And that's over what? An 8. And so I now have this at 23 over 8, and you have an option to rewrite that as a mixed number. Now, the reason I bring this up, this was a point of discussion yesterday for about 10 minutes. And I'm not critical of the fact that you had the questions. But my point is, that shouldn't have been a problem. This should not have been something that just didn't click, and yet it didn't. So where are our problems? Are they in the pre-algebra? Are they in the arithmetic that we were supposed to have as a background just a half a semester ago? And I argue it's with the arithmetic temporarily. And for your information, whether it's pre-algebra or algebra, when you hit problems, it's usually not the algebra. It's the arithmetic that you aren't remembering. Now, there's a difficulty. Any course you have, you tend to do what? Forget it as the time goes on. You had a break between semesters. And then you come back in and you do other things, and the mind sort of lets go of what you've had before. That's part of the problem. I'm going to make another statement as an observation as a person who took math course after math course after math course. When did you learn the material in, say, Math 10? It's really when you took Math 20. That's when you really made it solid. When do you really handle all the stuff we're talking about in the pre-algebra course? Probably in a Math 70, the next course. You're going to have the understanding that you wished you had right now. And how are you going to really solidify what you have in a beginning algebra? When you take the intermediate algebra. It goes right on up through that. You take a first semester calculus, and there are pieces that just don't click maybe. Take the second semester calculus, and now you really understand the first semester. So the key is never stop taking math courses. You'll always understand the previous course better. Simplistic, but that's the way it's worked for so many people. And how do you best understand anything you take? Teach it. You'll get more insights, more understanding than you ever did as a student. That's why I keep telling you, explain to each other, help each other. That's where you're going to benefit. So, that was a very typical problem. Now, questions you have. Shamra?
I can't remember which one that I was having problems with.
Can you find one in your book very similar to it? While you're looking, I'll ask Sandra's input.
Okay, my problem was off of the computer.
Okay,
It was evaluating an expression.
so we're going to evaluate an expression. So, Ernie, I'm going to go up here and evaluate, which means you're going to substitute, right? Evaluate means plug in, chug. Plug in a value, get an answer. By the way, Tabitha, if anybody has any questions about how to shade in, should I just send them to you? Okay, I will do that. Okay. Now, I'm going to evaluate an expression. Sandra, can you give me the expression?
Yeah, when X,
Well, I need the expression.
it didn't give me one.
Didn't give you an expression? What is it supposed to be, James?
X plus B, C.
Ah, x plus b times t. That's my expression. Okay, see, I can't evaluate something if I don't have the expression. Now, what's the x value supposed to equal?
X equals 4.5.
So x is 4.5. Let me ask you this. If I just said x equals 4, would it give you as much problem? I wouldn't think so. Okay, and I need some more. What else?
B equals 38.
V is 38.
And
T is 1/4. Do I have it all?
Yep.
So I'm going to evaluate. Translate, substitute into the expression. So I have 4 1/2 plus 38 times 1/4. Is that much different than the problem I just did?
I did it now.
No. Now you're okay.
Yeah, apparently I didn't write down what the expression was.
Oh, you didn't.
So I was like,
You're right. If you didn't have the expression, then you evaluate, you are in trouble. So now that you have the expression, you're good. Okay, by the way, since I want to hit a point again, this is really 38 over 1. And then I could cancel. They're both even. Oops. Now, if the text had been really kind to you, they would have used 36. But then that wouldn't have made it fractions. So this becomes a 19, this becomes a 2, and I really like that because I'm going to have a 2 here. So this became 9 over 2 plus 19 over 2, and that's 28 over 2, and that's 14, and now we're done. Shamra.
Okay, it's number 8 on the book.
Number 8 out of the book. So I'll come back to Senator Ernie and pick up number 8. I need to get to the page where 8 is. Okay, I got there. 373, is that right? Okay, we just have some fun here. Okay, let's go with it. That's what I have. And this could be a Math 10 problem, could it not?
Right.
You could put this right into the Math 10 book. Number 8. Okay, so that is 5 1/3. And I have it added to a 3/4. And I have it divided by a what? 5/12. Order of operations says what as I look at the problem? Division first, right? While I'm at it, I think I'm going to take the 5 1/3 and make it 16 over 3. Improper fraction? Okay, I'm not going to do anything more than that. And then I'm going to rewrite this as 12 over 5, correct? So I sort of like that because the 4 goes into the 12 3 times. And you can't cancel the 3's because they're both in this top. So I have 16 over 3, and I have a 9 over 5. Do I need to go further? I mean, I should go further, but do I need to do it as far as the presentation? I mean, I'm not dumb, but if I can stop, I will. Okay, so we're okay at this point, and I'm just going to put ETC, etc. Now, I'm sure somebody watching this, somebody else says, yeah, I want to see it done. James. Okay, is it computer or in the text? Computer-based. Okay. Okay, I'll just listen. Ah, okay, so some statistics. The mean, the mode. Do you have the fractions you can give me? Let me write down the fractions you give me. 5 1/2. 6 1/4. 8 1/4. 8 3/4. 10 3/4. 11. This is just the beginning.
That's the length and then the width. I mean the weight. It's two different fractions. It's 12 fractions altogether. You have to find the mean.
Of all of them? So these are the first 6, and I have another 6 I'm going to write down, and I'm putting them all together.
First you have to find the mean.
Of that. Do I have to find the median there also? Okay, what's nice about what you just gave me when you read them to me? They're sorted. They're in order, correct? Okay, but you were very kind to me. I appreciate that. Sorting fractions is not as easy. And now I have 6 of them, correct? And so the median will be between the third and the fourth, which is 8 1/2. Right? Okay, Ernie, I need to have a little more space or something so I can walk in and out of this without being off camera. So now, I don't need too much there. I just need a little bit more over here. Now, question, Isaac.
I was hoping, can I change the fraction to a decimal?
Not yet.
No, because it'd be so much easier to organize.
Okay, I see what you're wanting. You want to get rid of these silly fractions and replace them with decimals because they're easier to work with.
Yes.
Not now. The idea is suffer with the fractions a little bit longer. Suffer with the fractions a little bit longer. You should get better at fractions. Don't get rid of the fractions and trade them in for decimals yet. Now, a week or two from now, won't have a problem with that. But part of the game here is to get comfortable with fractions. I know, but you aren't going to get more comfortable with it by avoiding them. Okay, avoidance does not gain familiarity. Contempt, maybe, but not familiarity, and I want the familiarity with the fractions. Now, do you see how I got the 8 1/2? It's between 8 1/4 and 8 3/4, and that's halfway in between. The median is easy. The mean is not so easy. So what was your notation for the median? X tilde, right? Now the mean, I have to add this mess up, and fortunately, the common denominator would be 4. So life isn't too bad if I treat this as 5 2/4. Then I have 2, 3, 4, 7, 10/4 on the fraction portion. Is that correct? And then if I go ahead on the other, I have 11, 19, 27, 37, 48. And so then you take the 10/4 and you say you have 5 halves. And 5 halves is 2 1/2, so that makes you 50 1/2. Do we agree? And that's X bar, which is called the mean. I got to divide by now what? Thank you. I need to divide by how many I have, which was 6. Thank you. So I'm going to have what? 50 1/2 divided by 6. So you could either actually physically do this, which would be what Isaac would love to do, or you go ahead and say that's 101/2 times 1/6, which is 101/12, and that would be my mean, whatever it is. Question? Well, 12 would, yes, it will be 8 5/12. So this becomes 8 5/12, so X bar is 8 5/12, which is just slightly different than X tilde. Jessica?
Why did you put it 1/6 and 6 opening and dividing it, never mind.
Thank you. Okay. Since I'm dividing by 6, I wanted it 6/1 so I can invert and multiply, and I nearly forgot to divide by 6 until Michael asked his question. I was not going to get the mean. I was just going to get the summation of all the values. Okay, good point. This comes back to Isaac's disclaimer. If you could just get rid of these fractions and replace them by decimals, my time commitment would be cut in a fraction of what it is with the fractions. Right? It's the fractions that is making it tedious and time-consuming. Yeah, it's just, but it makes fractions more familiar to you. And I like the familiarity of fractions. Friendly fractions. Other questions? Another question. Which one? Number 1 on the computer. Okay, I have no idea where I'm going to have space. Read me the question first so I have an idea what you're talking about, and then I'll decide where I have to go. Ernie, you probably better go camera 1 here on me and free up 2. So up here I'm going to try it. This is a problem from the computer. So number 1 on computer. Okay, so you have what? 2/5. Negative 5/4. Parentheses. 2. 2 3/4? 2/5 divided by, and then parentheses here, minus 5/4. Is this the way it's written now? None there? So it's like that. Okay. What gets done first? Can't do anything in the parentheses. Now, wait a minute. Whatever is after, I'm going to put something here to break this up. Whatever is after the division symbol gets inverted. So your next step is going to be 2/5 times, and I'm going to use a dot because I think the text is using the dot a lot. And then it's 4 over negative 5. And then I still have this subtraction, and I think I would immediately go to 11/4. Now, there's nothing nice about this one because it would have been so much nicer if it had been a product. You can't cancel. You've been cheated. Been cheated. I don't know. You've been hornswoggled. 8 over, that's negative 8 over 25 minus 11 over 4. Now, just looking at that for a moment, James, I'm going to have to find a common denominator, which is 100. It's not a nice problem. Nothing good about it. This is going to have to be negative 32. So you're going to have this becoming negative 32 over 100. And then this one is going to have to be a negative sign also. And I have 25 times 11, which is, well, 25 times 10 would be 250. So how about 275? Is that correct? Didn't sound good. But I think I'm supposed to have 275, am I not?
Yeah, that's probably right, but I timed it by 20
Instead of 25. Now, again, I'm not picking on you, okay? So understand that. But multiplying by a 20 instead of a 25 may seem particularly rational and reasonable at the time, and you'll be inclined to go way back up here and hunt for something you made a mistake on, and you spend 10 minutes saying every part, and I still multiply by 20 at the end. There's not much of a way to prevent that from happening, and when it does, about the only thing that I've done is start over and hope that you didn't remember that 20 times 4 was 100 instead of 25 times 4. But I have looked at problems, and as recently as yesterday morning, hunting for a mistake I couldn't find. Yesterday, Raylene had a question in an algebra problem, and I looked at what she had done. I looked at it for several minutes. It was an algebra problem, much that you've done. It involved taking the product of two binomials. I could not see the mistake. And it turned out she had subtracted something from both sides, but had not subtracted it on what she wrote. And so it just didn't work. But I looked at it for several minutes and could not see the mistake. That happens. So how do you know when to, you get down to here, it's not a green. You carry this through. This, by the way, becomes what? Minus, we have a 7 there, a 10, minus 307 over 100. And, of course, that's not what you would get with the 20. And so this is what you're supposed to get. And you could spend 10 minutes in the computer trying to get something that worked that has a snowball's chance in wherever to work, because you did a simple arithmetic kind of thing that we do under stress, being tired, the things where you look at it and it seems reasonable for at least a minute and a half, and you ask somebody else to look at it and they see it and say, well, why did you do that? And you look at it and have no idea in the world, but you didn't even know you did it. That, in a way, Shammer, coming back to the statement, why do these problems take so long? There are so many places to make errors, so many places to have some little part that's wrong, and there isn't a single question I've been asked today that is Math 20. Just let that sink in for a minute. Now, I wasted 10 minutes talking about just general kinds of things, but we spent 25 minutes, and I haven't done a problem that I would consider a Math 20 problem. Everything we've talked about, I would have expected you to do in a Math 10. Other than that first problem, as we swing over here with just the camera you're on, Ernie, that would have been a little bit beyond Math 10, because I had to do this in parentheses first. The rest of what we've talked about, Math 10. So what is it you're battling? Well, the same thing I tell my stats students. They've had 2 semesters of algebra, beginning and intermediate minimally. Most of the battles I have don't have a thing to do with statistics. They have to do with their background. I took, listen to Sarah talk about her pre-calc. And the problems they are having are at least a semester to 2 semesters back in an algebra course, where she says, do you remember doing this? And they just look at her and say, No. Now, she doesn't know if they didn't have it or they just have no memory. And that's possible. Because you can forget things so fast. But understand the difficulty today. Not a thing to do with 20 so far. Michael.
I got a 20.
You've got a 20. Okay. You want change for it? Okay, we're going to go to the sideboard. That was a smart aleck response. Okay, Ernie, thank you. What do we have?
It's number 3 from the computer.
Number 3 from the computer. Number 3 with a bullet. Okay, what is the problem?
It's
4.5.
minus 2.
Minus 2.
Radical.
Oh, a radical.
50 over 2.
50 over 2. I had a question of this yesterday. We could have done this in Math 10, and we did do radicals. What's the key? Divide here first, inside the radical, because this is really 9/2 minus 2 times the square root of 25. Yes?
Last week, you found the squares for both numbers.
Well, I said we could do this, but you have to know when to fold and when to hold.
And I seen the 2, and I was just going, what?
Now, you couldn't do anything with that, but you had this option.
You can do this?
I can simplify inside first. Now, when wouldn't you want to do what I did here? I wish the problem had been given differently. If it had been given as the square root of 50 over 9, then would you have had an option? No. Because you would want to do this so you could pull that 3 out, right? Okay, that is an option. Okay, you chose that option. But that doesn't help you in the 50, right? Now, it turns out 50 can be written as 25 times 2. Then we could take out the 25 and say 5, the square root of 2. But you're still ultimately left with a square root of 2 in the problem. That becomes a whole new issue when we want to get rid of radicals. How do you do it? Well, fortunately, we don't have to deal with that. This was a nice, easy part here. And so that's minus 2 times 5, again, trying to avoid the x for multiplication. So that's 9 over 2 minus 10, which is 20 over 2. So that's minus 11 over 2, which you'll also know is negative 5.5. If I did not make it look easy, you should fire me. Okay? This was a 10. 10 over 1 was 20 over 2. I wanted a common denominator, so I just skipped a step.
Okay, now I get it. Okay,
Okay?
How you got a 20 again? It's 10, right? So
This is a 10 over 1. This is a 9 over a 2. What's my common denominator? 2. So multiply by a 2 here, and multiply by a 2 here, and that became this. You're welcome. Thump. Any other questions on this problem? Now, if I misled you by saying do this, there is an out here. Okay, this is some risk, but for those of you going on, who I hope will be all of you, you don't like that there? Multiply by the square root of 2. And multiply here by the square root of 2. What's the square root of 2 times the square root of 2? 2. This becomes the square root of 100. What's the square root of 100? 10. And that's the way I would have done the problem.
yeah, I'm not there yet.
And that's the same 10. We got, just a minute, I had, this was multiplied by 2, right? So that would have been then 2 times that. So this then becomes, do it this way, because you were multiplying 2 times that, and I'd have 2 times 10 over 2, and that would have become 10. Same answer. That's called rationalizing a denominator, trying to get the radical out from under the denominator. And the reason for it, the square root of 2 is 1.41 with garbage that never stops. And you don't know how to divide by a decimal that never stops. Like pi, square root of 2, irrational, goes forever. So, but if I can divide by 2, that's cool. I can divide by 2, not a problem. But try dividing by 1.41 and lots of garbage to go. It's impossible division. So we avoid that. And this, again, is called rationalizing the denominator. It is irrational. How do you get rid of the irrational? Make it rational. Some interesting political overtones there. Jessica.
When will we actually have to use that?
This up here?
Yeah.
In another lifetime in a week or two.
Okay, just want to make sure.
Not yet. Okay, not yet. No. That's a problem we would hit in 70 minimally, and we may deal with it in 20. In fact, we just did. Okay. Any other questions from those problems? Shamra? Okay. We haven't understand what we're battling. Because the whole issue, as you all walked in the door, this is taking forever. Okay. But I think I have this assignment open tomorrow. And if it's going to take forever, I'll probably open it until Monday then. Okay, so that'll get you a chance to have more pleasure with this. Some of you may say, hey, close it now so I can be done with it. Okay, we'll leave that there. So I will reopen. Now you say it's open until tomorrow? So I don't have to rush at the end of the hour now and try to reopen it. I can wait until later today, early tomorrow morning, 4 a.m. would be okay. Mental note. What? I'm sorry, it just went out of my head right then. There was some humor in that. Unfortunately, closer to reality than rumor, okay? Humor and rumors and so on. There were no problems with the diagrams? You didn't get there, okay. Number 5 out of how many? Out of 20. Okay. So there may be more questions tomorrow. Okay, so tomorrow we will probably still be on this. So, okay, the question, is there something that's easier? Yes. No, not for fun of it. I only have 15 minutes to cover what little new I can do today. And I want to try to bring, I'll come to that tomorrow if you're here, Isaac. Just wanted to, fair is fair. You always have the feeling that when we go on, it'll be worse. Sometimes it's a roller coaster that gets easier. Okay? So let's go to the document cam. Number 12. 2/5, in fact, we have two problems here. 12 and 9 are two nice problems that I can look at. And my point is, these are not, they better not be, hard for you. I'm going to go to 9 first. This is in 5-8. What page am I on? 386? 386? That was a good computer at one point. Let me write this down. It's 5/6 plus C equals, you said 3/5? Okay, and then I'm going to go down to, thank you, Ernie, number 12, which was 2/5 B, and that equals 1/10. Now, coming back to the board. First note. I'm going to write two similar problems, and you tell me if you have trouble with either of them. Okay? I'm going to tell you that 3B equals 6. Can you do that?
Yes.
Oh, that was fast. Yes. Agreed? You can do this one.
Yes.
Everybody. Yes? Yes. Yes. Not a problem. What are you going to do? That's the answer. What are you going to do? Not the answer. Divide by 3 and you're done, correct? Okay, if that's how you do this one, then what are you going to do here? Well, you could say divide if you want to be consistent, or you can say multiply by the reciprocal. Reciprocal, invert. So I could have multiplied by 5 over 2 and do the same thing on the right side. And do you note that's exactly what I would get if I did the division? So this is going to be B. And here the 5 cancels and you get 1/4. Now my point is, this problem you don't even have to think about. But what you do here, you do with fractions. That's the key. A problem with fractions, ask yourself, what would I do if I didn't have to do a silly fraction? If I just had 2b equal 1, divide by 2. Or multiply by 1/2. Okay, up here. New problem. 5 plus c equals 3. What would you do? Add minus 5 to both sides, right? Or subtract 5 from both sides, and you get c equals minus 2. Not a problem. Okay. Instead of adding negative 5 to both sides, let's add negative 5, 6 to both sides. Or subtract 5, 6. That's going to be c. And I have 3 over 5 minus 5 over 6. Note you cannot cancel the 5s. It's a subtraction, not a multiplication. And the LCD is 5 times 6 because they're relatively prime. That's a problem you've done before. Unfortunately, we're going to get a negative out of it. But that's 18 minus 25 over 30. Which is a negative 7 over 30. You're done.
I got the 18 and 30 with the 25.
I had to multiply here 6 and here a 6 to get my LCD. And here a 5 and here a 5. Okay? Got it now? Okay. Not so bad. Back to the document camp. They're all like that, right? Easy compared to what we've been doing so far. Well, let's just keep going. Do they get any worse? Okay, so now we're down at 21 and 24. You've got 2 sides to the problem that needs simplified. And so what am I going to do as I try to argue with you? In 21, I have 1 over 8 plus n, 5/6 n minus 2/3. Now, I'm just going to change the problem. I have 1 plus n equals 5n minus 2. Forget about the denominators for a moment. What would you do? Oh, I would subtract n from both sides because I like to have a positive coefficient. So you'd have a 4n here, and you'd add positive 2 to both sides. And you get 3, and you'd say n is 3/4. Not a problem, right? I'm asking, what would I do if I didn't have those silly denominators? It wouldn't be hard. Agreed? Now, this isn't an answer to the problem I was given. It's just my point. This you're comfortable in doing. Okay, so what did I do? I wanted to get the ends together. So I got this end from here over to here. Okay. So as I rewrite that, on the right side, I'm going to have 5 over 6 n minus an n. And I want to get this over here, correct? I want to add 2/3 to both sides. So I have 1/8 and 2/3. But what's guiding me? Knowing what I did without the fractions. Okay. You have to be careful. This is minus 1n, so that's minus 6n. I have 5, 6, and I have minus 1. I have to have a common denominator. And isn't a minus 1 the same as minus 6 over 6? Yeah. So this right side, which I'm getting all sorts of looks, is n times 5 6 minus 1. So you change this to n times 5 6 minus 6 6, which is going to give you n times minus 1 over 6.
Why wouldn't you put the n on the other side with the 6 on
I could have.
That was confusing, but
I thought I was going to, well, I was trying to do what I did here.
Oh, okay.
In a sense, I brought the n over to the right side. I'm just trying to replicate. I agree with you, Jessica. It would have been better on the left side because I would have had a positive 1/6 then. So I'm not real happy with myself. I didn't anticipate that until I'd already committed. Okay, what about over here? 24, LCD, they're relatively prime. So I'm going to have 3 plus 16 over 24. So that's going to be 19 over 24, correct? So what I have now is 19 over 24 is equal to negative 1 over 6 times n. What do I want? N by itself? Don't no, not add, not subtract. How do you get rid of a factor? Multiply or divide. Okay, you need a bumper sticker. Cancel factors, subtract terms. This is a factor. I want to get rid of it. I can divide by them. If I want to get rid of terms, subtract them. So I can divide by negative 1/6, or do what? Multiply both sides by negative 6 over 1. And this does cancel, and so I have negative 19 over 4 is equal to n, and you have a choice. I think this is negative 4 3/4 equals n. Okay. Fractions are friendly. That's your mantra for the day. I love fractions in the morning. I love fractions at night. Fractions are nice to have, right? Then you eat them for breakfast. It's bad as my humor. Okay, now we get a few nice word problems. Now, don't groan yet. Good grief. I say word problems. Ugh, sound like a sick calf. Okay. Something of a number is. Okay, does that say 3/8? 3/8 of a number. So 3/8 of x is... What is the number? I need to have that back again. What is it? 4 5 6? Now, if I said 3 times the number is 8, that would have been an easier problem, right? I think maybe a little bit easier. Maybe if I said twice the number is 8, that would have been real easy. 2x equals 8, x is 4, you're done. What are you going to do here? Back to the same question. You didn't like the negative 1/6 here. How did you get rid of it, Jessica? She said subtract it again. You are really consistent. You want to say divide or multiply. It's a factor. So how am I going to get rid of this factor? Multiply by its reciprocal, both sides, or divide by 3/8 both sides. Not a hard problem. That's my argument. Because there aren't as many fractions to do. I'm going to go back to James's problem with the means and the medians. That was a tough problem. We had 6 fractions all at once. Well, there were 12. Well, I did half your problem. But the point is, 2 fractions, a lot easier. Yes? Shamra, do you agree with that? You can do these? Okay. I feel like we're getting coached up, ready for a match, soccer match or a football game. Get you. Okay. I'm going to ask that you work really hard tonight finishing up 5-7 so that tomorrow in the tutorial we can bring closure to that. Play a little bit with 5-8 and see if my argument is valid. This isn't tough. And then you still have 2 more days after tomorrow to work on 5-8, and it's a lighter fair. Seem reasonable? Okay, that's a commitment. I heard that promise. 5-7 will be done. Okay, Ernie, you've had all...